Welcome. Today is Wednesday, August 25th, 2021, and this is the Regulators Financial Toolbox on Resilience Technologies. We can go to the flip 2 slides, please. This is a program from the National Association of Regulatory Utility Commissioners, which is the nonprofit organization that includes all 50 state and territory public utility commissioners that regulate essential services like electricity, natural gas, telecommunications, and water. The Center for Partnerships and Innovation team is grant funded, and we identify emerging challenges and connect our commissions with expertise and strategies by building relationships, developing resources, and putting on events. And we thank the U.S. Department of Energy for supporting today's session and the toolbox overall. So on the next slide, we have an overview of the toolbox series, and this series addresses a technology, its benefits, and how a regulator can approach regulating the utility to implement some of the technologies. So we've started the series with cloud computing last fall, and so we're excited for today's program on resilience technologies. It's been in the making for quite some time. So if you have any ideas for future programming, please let me know as soon as possible. We can go to the next slide. Today we have 4 excellent speakers. We have somebody who will help us understand the technology and ground us in technology. We have 2 folks from Sandia and Synapse to help us think about frameworks for how to think about the benefits of these technologies. And then finally, we have a Public Service Commission staff member who will provide a case study. So without further ado, I would like to introduce the moderator for today's session. We have Chair Carrie Zalewski from the Illinois Commerce Commission, and Illinois has been great in being a leader in resilience technology. So we're very excited to have her and their perspective moderating today's session. So I will let her introduce the panelists and get everything going for us. So Chair Zalewski, take it away.
Thank you, Kerry. I am honored to be here. Again, my name is Carrie Zalewski. I serve as the chairman of the Illinois Commerce Commission. And I must start by saying that these are my thoughts and my thoughts alone and don't necessarily reflect those of the Illinois Commerce Commission. Thanks again for the invitation to moderate. And thank you to NARUC for putting together today's panel entitled Regulators Financial Toolbox on Resilience Technology. As Kerry stated, this is a part of the Regulators Financial Toolbox series, which examines regulatory issues where technology meets bookkeeping. In today's webinar, speakers will discuss technology and address economic and accounting considerations for resilient technologies. The DOE has defined resilience as the ability to prepare for and adapt to the changing conditions and withstand and recover rapidly from disruptions. A new Sandia report, and of course Sandia is one of our national labs that is located in New Mexico, was printed in June of 2021 and explores regulatory mechanisms to enable investments in electric utility resilience, which explores a consequence-based approach for grid investment for designing resilient communities. We have 2 of the contributors to the report today, Jen Kallay and Dr. Bobby Jeffries on the panel, and I'm looking forward to hearing what they have to say about the study. This study explores a range of regulatory mechanisms that jurisdictions have deployed to improve resilience outcomes, mechanisms such as performance-based regulation and integrated planning and tariffs, and programs to leverage private investment, just to name a few. If you have not done so, I recommend everyone to read the article. I'm going to put a link in the chat so that you can access and read the report at a later time. Now in Illinois, resilience, reliability, innovation, coupled with a call for decarbonization of the state energy sector, often occupy a large space in the legislative debate and regulatory decisions. Illinois has completed its transition to the AMI infrastructure upon the legislature's directive that used a performance-based regulation like to incentivize utilities investment and prompt deployment. And ComEd has deployed smart meters to nearly all of its roughly 4.2 million electric customers. Ameren has deployed smart meters to nearly 100% of its roughly 1.2 customers. Ameren is also installing natural gas modules at its gas customers, roughly around 800,000. More discussions are now pending as the Illinois legislature discusses a potential new energy bill that could call for new approaches, including a integrated distribution planning and incentives for distributed energy resources and EV deployment. Now, if this passes, this new legislation would rely heavily on the Illinois Commerce Commission's expertise to implement these new directives and find efficient ways to ensure the resiliency of the grid with the transformation that is coming. And that's why conversations such as these are so important to commissions like the Illinois Commerce Commission. Also relevant to today's conversation, I wanted to note that Illinois has 2 utility scale microgrids, the ComEd Bronzeville Community Microgrid in Chicago, with about 7.5 megawatts of peak load, which includes storage and solar. Also, Ameren's microgrid in Champaign, Illinois, with 1.475 megawatt load, including wind and storage. The commission also recently approved dockets to incentivize EV charging during the off-peak times, and even opened a notice of inquiry to review extreme weather impacts on our grid. Extreme weather impacts are, of course, an important part of the conversation on resiliency. Now, before we begin, before we get to our speakers, I thought it would be great to have a poll question so that we could get a sense of what resiliency technology and regulatory mechanisms you are most interested in learning about. There are 7 choices, so I'll give you a little time with them. I'll read them right now. So the question is, what resiliency technologies and regulatory mechanisms are you most interested in learning about? Options include performance-based regulation, integrated planning, tariffs and programs to leverage private investment, alternative lines of business for utilities, enhanced cost recovery, securitization, and then others. So feel free to add into the comment section. We'll give it another 30 seconds. So please take the time to enter. Last call, I'll just note 2 things that the speaker bios and presentations, I think Carrie put in the chat box. She linked it. So if you want to find out more about the speakers, feel free to click on that. I also included, I just added the Synapse report to the comments as well. So feel free to click on that if you would like to actually read the report. About 10 more seconds. Okay, it's a mixed bag, but it looks like the winning choice is integrated planning and performance-based regulation, and then some interest in enhanced cost recovery. But it looks like there's interest in all topics, so that's good for the group. Thank you for everyone for participating. That's very helpful to myself and our speakers. So without further delay, I am going to turn to our expert panelists. I'm going to introduce each panelist right before they speak and let them present. And then if you have questions for any of the panelists, please think about them now and enter them into the chat box, and we will have hopefully an ample time to answer questions. So please start thinking about them and feel free to add them either as the speakers are speaking or at the end. So our first panelist is Julio Romero Aguero. He is currently the Vice President of Strategy and Business Innovation and Executive Advisor at Quanta Technology. Julio is a former commissioner at the National Energy Commission of Honduras. He has extensive utility experience with emerging technologies and has authored over 60 technical papers and presentations. We're very lucky to have Julio here today. He will be discussing emerging technologies for resilience. Julio, the floor is now yours.
Thank you so much. Thank you for that introduction, and it's a pleasure to be here. I really appreciate it. Can you see the presentation on the screen? You can see it, right? Okay. So, so what we'll try to do, I have around 13 slides and only 15 minutes. So I'll go through the first slides fairly fast, and I want to focus. I have a specific slide that I want to that I want to focus on. And so we'll get to that one fairly soon. So next slide, please. Okay, something that is important that we discuss is this is an interpretation, let me put it this way, of reliability and resilience. Reliability, we know that it's well known, it's established, it's standardized, we have been using it for quite some time. Although resilience has been there, it has been receiving more and more interest in the last 10 years, I would say. So it is important to discuss some of the differences between them. Reliability is in general accepted as a system performance measure. We use reliability to assess the performance of a system, while resilience is understood as a system characteristic, as a capability of a system. Something that is important here is that there are many interpretations to resilience. I used to say that it means different things to different utilities or to different people. One of those interpretations tend to focus on extreme events, major events. Other interpretations actually cover all types of events. So this definition that I'm sharing here is more related with the latter. It's a system characteristic, therefore is a system characteristic that is associated to any type of event, including those high impact and low frequency events that are traditionally associated with the concept of resilience. Something that is important is that why do we want to approach it this way? Because some of those high impact and low frequency events are actually becoming more and more common because of climate change. At the same time, although generally when we improve reliability, we tend to improve resilience and vice versa, sometimes they have opposite effects. I'll give you an example. For instance, when reclosing is a very common practice in distribution systems and also in transmission lines. But sometimes, for instance, let's think about California. The practice of reclosing may have negative impacts. It may ignite wildfires. So in that case, although reclosing improves or is has been used to improve reliability, the effect in that specific case may be to worsen resilience. Next slide, please. So as I mentioned before, there are several different definitions of resilience. Several organizations have contributed in that regard. FERC, DOE, the North American Transmission Forum. There are several definitions, and recently, last year, we contributed to a report, a technical report by the IEEE, the Institute of Electric and Electronics Engineers, specifically working with the Power and Energy Society. In that report, we also contributed with a definition from PES. There was an existing definition from PES, and we expanded that definition. We'll talk about that in a moment. So next slide, please. And it goes back to what I was describing before. This is the report, is publicly available. It was put together by a team of industry experts. And the definition that is included in that report is the ability to withstand and reduce the magnitude and or duration of disruptive events, which includes the capability to anticipate, absorb, adapt, and or rapidly recover from such an event. Something important here is that we are talking about any type of event. We are not limiting it to those major events that, as I mentioned before, typically the definition of resilience used to focus on. Next slide, please. Why is it important? I think that we are, I'm preaching to a choir here, so I'm not going to spend too much time here, but something that I want to highlight is that it goes beyond the importance of resilience, goes beyond the electric power grid. because of the different interrelationships and interdependencies of the electric power grid with other grids, with other critical infrastructure, natural gas, transportation, water, telecom, etc. That's something important to keep in mind. And also the scope of resilience. More and more, there are new threats, new potential events that affect the power grid. We are experiencing one of them, pandemics, but we have a variety of events, variety of aspects that need to be considered: cybersecurity, physical security, geomagnetic and electromagnetic pulses, aging assets, climate change, etc. So that's very important to keep in mind, since we have a variety of threats or of potential sources of disruption. Therefore, we need also a variety of solutions. Next slide, please. So we need a variety of solutions, but we also need a way to measure resilience, and a way also to measure how those solutions may improve resilience. And this is a challenging task. It's a work in progress. There are a variety of organizations working in this area, but we haven't reached the point in which we have something that is standardized and widely accepted by the industry, which is where we are right now with reliability, specifically distribution reliability. We have reliability indices that we have used for quite some time. We are not there yet with resilience, but there are some activities. For instance, DOE has put together recently, last year, they published a report that includes two sets of metrics. Multi-criteria decision analysis metrics that are more qualitative in nature, and performance-based metrics that are more quantitative in nature, and they are described in this table. At the same time, the IEEE Power and Energy Society, one of our working groups, the Distribution Resilience Working Group, which is a working group that I sponsored when I was Distribution Subcommittee Chair, they are also working on defining resilience metrics specifically applied to distribution. And as I said, this is still a work in progress, but we need to accomplish this, so we have a systematic way to measure resilience and to use that to evaluate the effectiveness of solutions. Next slide, please. This is just an example of that multi-criteria decision analysis metrics. What I wanted to highlight here is that it's important that metrics are relatively easy to calculate. For instance, although this is a qualitative evaluation and it's very comprehensive, it requires a lot of effort and a lot of data, a lot of information to calculate. So that's a challenge in this regard. So we need to find a way to calculate resilience using an approach that is relatively simple, but at the same time it captures the essence of resilience, and that's where the challenge is, because it's a complex task. Next slide, please. At the same time, we also need to find a way to calculate the value of resilience in the same way that we have approaches to calculate the value of reliability. For instance, the interruption cost estimator, the ICE calculator, developed by Lawrence Berkeley National Lab, is a tool that we use, many of us use to calculate the value of reliability. We need something equivalent on the resilience side of things. And there are a variety of approaches, and this slide talks about some of them. This is just for your information. So you can see that there are many parallels between reliability and resilience. The main difference is on the resilience side of things, plenty of this is still work in progress, but everything starts with that definition that we described, that I described before. Next slide, please. And this is the slide that I wanted to discuss with you all for a moment. So we talked about solutions, right? We know that resilience is a challenge, that we need to improve it for a variety of reasons. So how do we do that? Traditionally, the approach to resilience improvement was more related with foundational infrastructure, with the foundational assets, with poles, with overhead lines, with substations, etc. It was approached from the point of view, largely from the point of view of hardening. And still today, for some utilities, resilience is almost equivalent or equates to how do I improve resilience? Through hardening. But it's much more than that. But certainly, those solutions need to be used, address the foundational infrastructure. More recently, I would say the last 10 years, and especially the last 5 years, technology solutions have become quite important. So we are looking at protection, automation, control, at advanced modeling, planning. There was in the question, I was glad to see that integrated distribution planning was one of the was the most important, was the winner of that poll. So integrated planning is very important. Real-time operations. I mentioned advanced automation and control. DER, the adoption of DER has created a variety of challenges, but it's also introducing a variety of opportunities. So within DER, we have microgrids, we have distributed energy storage. We also have, in general, non-wire alternatives. So that's another aspect of resilience, another way to improve resilience. But we also have to look at, I would say, solutions that are not necessarily technical. We have to look at logistics. We have to look at staffing and at processes in general. I think that the pandemic last year gave us, provided very good lessons learned. And one of them is what do we have to do, or how do we have to prepare against the potential disruptions in supply chain. So that's not necessarily a technical problem. It's more a problem of logistics, right? A problem of processes. So in this slide, what I have tried to do is to capture all of those different possibilities. We have to look at asset management. We have to look at maintenance. We have to look at sensors, intelligent devices. We have to look at physical and cyber security. The more traditional reliability improvement as well, as I mentioned before. Generally, when we improve reliability, we also improve resilience. We just have to be careful, like in the example that I provided. We have to be careful and identify those potential opposite effects that I mentioned. We also have to look at the relationships with other critical infrastructure. We have to look at telecom, at gas, at IT. Each one of the bullet points here provides an example of those potential solutions. If we want to focus on technology, for instance, let's go quickly. Initially, I mentioned integrated planning. So the ability to model the T&D system in detail. So high resolution temporal analysis and highly granular spatial analysis that allows us to identify system needs at a very granular level, even at service transformer level, distribution service transformer level, and then identify also outline solutions to address resilience needs at that level. And addressing those resilient needs can be done, for instance, with distributed resources, with NWA. Automation and control, for instance, talking about Illinois, very familiar with some of the work that has been done in Illinois with the EMA initiative, the deployment of thousands of smart switches and implementation of advanced distribution automation schemes, and how that improves not only reliability, but also resilience. Real-time monitoring and control, increasing awareness, especially over the distribution grid, that traditionally, historically, has not been observable. That also provides a variety of benefits. So let's go to the next couple of slides. There are some examples, real-life examples from utilities. This is from Florida Power and Light. So the work that they have done is remarkable. And they have focused, initially, I think that the focus was more on the hardening side of things and undergrounding, targeted undergrounding as well. And more recently, they are also focusing on automating distribution systems, automating feeders, deploying intelligent devices, advanced sensors, for instance, fault circuit indicators with the capability to be monitored remotely, and also the capability to collect high resolution fault currents, which can be used through data analytics, through predictive analytics, to identify, to prevent, eventually, ideally, potential system disruptions. Next slide, please. Another example of how resilience can be improved in some cases as a byproduct of the deployment of advanced technologies. This slide. This is from Hawaiian Electric. This is their vision for grid modernization, and you can see that it includes a variety of technologies that are going to improve resilience. I mentioned intelligent switches, remote fault circuit indicators, sensors. They also are working actively on smart inverters and smart inverter standards, inverters that have the capability to provide support to the grid, substation automation, battery energy storage systems. This is a really nice technology, basically power electronic devices that are used for voltage regulation at secondary system level, which is something that is important when you have a proliferation of behind the meter photovoltaics. And those devices can be used in combination with those behind the meter resources eventually, and also with energy storage to create non-wire alternatives and potentially even to create neighborhood microgrids as a long-term vision. So the
Sorry to interrupt,
deployment
Julio.
of advanced technology.
Sorry to interrupt. If you could just,
Yes.
just so we can make sure we get to everyone, just wrap up in about another minute or two. We do have some questions coming in as well. I want to make sure we have time for those. Thank you.
Yes, no problem. I think that this is my last slide, if I'm not mistaken. So, so a variety of the deployment of advanced technologies has a variety of benefits, including improving resilience. Next slide, please. Let's just skip this one. I think that I talked about climate change already, so let's just skip this one and let's go to this one is important. So to close the presentation, I think that what is important is to define a resilience improvement strategy. And that resilience improvement strategy has 4 key components. How to prepare for emergencies is basically readiness or preparedness. How to withstand events, how to recover from events, and how to measure and improve events. And we discussed this all of these aspects in the presentation. Final slide, please. So what is important from my perspective is precisely to develop that strategy and roadmap. And as I mentioned before, you need to start with defining what your interpretation of resilience. Hopefully it is aligned with the rest of the industry. Find or define metrics to measure resilience. Define a portfolio of solutions, a goal, a target that you want to achieve, and then develop that roadmap for improvement. This is my last slide. Again, thank you so much for the opportunity, and I'm open for questions.
Thank you, Julio. That was great. I think level setting with the concept of resilience is an important point. I really appreciate the graphics. I always love a good Venn diagram, so I appreciate that. I'm going to ask one. There's one question. There's a couple questions from the audience, but I'm going to focus on one. I think it's a good question. The question is with regard to metrics. Is there progress in turning those metrics into measuring the dollars or cost effectiveness of investment, and what data is needed to measure the value and cost effectiveness of resilience?
Yeah, that's a very good question, and that's why I also mentioned the value of resilience. I think that we need there is a need for additional work in especially in developing a solution that is publicly available. I mentioned the ICE calculator, the interruption cost estimator solution developed by Lawrence Berkeley National Lab. We don't have an equivalent tool for resilience. I think that that's if we have somebody from DOE in the audience, I think that that would be a wonderful initiative for DOE to support, especially now that we are going to have additional funding. Yes, the short answer is more work is needed. We have methodologies. There are some methodologies available, and they are shown in that slide. You'll have a copy of this slide, so you can go to the slide on value of resilience. There are some methodologies, some approaches that rely on econometric methodologies. So there are some approaches, but we don't have anything that is publicly available. So there is a need for additional work in that regard.
Great. To be continued. All right. Thank you so much, Julio. We're going to move on to our next panelist, Dr. Bobby Jeffers, who has contributed to Sandia's energy resilience research programs since 2013. Bobby leverages a variety of modeling tools to better understand the human, natural, and engineered systems. He currently works across multiple federal agencies on energy resilience issues. Today, Bobby's going to speak to the framework for regulators to consider in the future. Bobby, the floor is yours.
Thanks, Chairman Zalewski. So one of the things that I think this flows nicely today is, Julio presented a difference between a more performance-based approach and what's been called the multi-criteria decision analysis type of approach. And I'm going to start to dig into more of the performance-based side and talk about some very, I think, tangible options, but ones that are a little bit more farther out and require a little bit additional investment before some of those are maybe ready for prime time. And then we're going to hand it over to Jen Kallay from Synapse to talk about some of the work that we've done together on more readily available options in the near term. So next slide, please. One of the things I think is important to think about as we've set up the resilience metrics and the analysis approaches that we have for resilience is to make sure that you're not really doing too much overlap in terms of the resilience metrics, both within the resilience dimension, but as well with other goals that you may have as a state. So if you look at the way that we've decomposed this, when we're talking about resilience, very aligned with what Julio presented, we're really talking about that society should withstand and recover, perform well during acute events, shocks to the system, even ones that we've never before experienced. And that's contrasted with something like efficiency or affordability, in which we want our systems to perform well on a normal day, right? And we have good planning mechanisms for blue sky, what we call blue sky planning. Some of our planning approaches are not as well evolved for the acute events. And that's largely because we haven't seen as many of those events. They don't happen every day. And then contrast that with something like sustainability, where we're really trying to make sure our system is not robbing from future generations to improve the current status. So we're making sure that that system continues to perform well over very long periods of time. So today I'm going to focus on resilience, but I think it's important to mention that within, you guys mentioned integrated planning environments, this is one of the aspects of integration, is thinking about how our resilience approaches either benefit or are in trade-off with, in competition with some of our performance in the other two dimensions. Next slide, please. So this is some of the history of the work behind the resilience metrics from DOE in cooperation with the National Academies, who released a report in 2017 recommending to DOE that we do a better job of understanding the customer and societal impacts associated with increased resilience to the grid. So we've done some work with Argonne National Laboratory and Pacific Northwest National Laboratory since that time to really extend what we're talking about, to really define resilience, and then to start to set up various metrics and approaches for quantifying that resilience. And the two main approaches that we've identified are called attribute-based, which is what Julio referred to as multi-criteria decision, analysis-focused resilience approaches, and performance-based. The rubric for this is if you can go out and count it today, then it's probably an attribute-based approach. So you might be able to go out and count how many spare transformers the utility might have. You might be able to count how much money is being spent on resilience in underserved communities. And that's all stuff that we think predicts resilience in the future, but it's not actually measuring what you actually care about at the end of the day, which is how resilient is my system when the hurricane comes or the cyber attack comes. And that's the job of performance-based metrics. So a performance-based metric, the rubric is you can only measure it if you're there during the event or using data that was collected during an acute event. And of course, this makes it harder, right? Because we have to set up the sensors or the capabilities to measure that. And because those events are so rare, especially the long duration ones. So we have to think about this from a modeling paradigm as well if we want to use a performance-based approach. Are the models ready to predict performance in the future, subject to alternative investments and increasing severity and frequency of certain types of events? Some common misconceptions are that one is forward-looking and the other is retrospective. No, both can be either retrospective or forward-looking. Both can be focused just on the power system or focused on all of society, and both can be either threat-informed or threat-agnostic. Next slide. So you may have seen this before. This is my version of the resilience trapezoid. It really serves to help think about what we need to measure if we want to take a performance-based approach. So we need to measure how the system is performing during the event, right? In a dynamic way. We need to have multiple measurements and we need to understand how far did it dip down and how quickly did it recover? Did it recover to the same point of performance as it was performing at before the event? And that type of thing, right? Notably, I didn't put kilowatt hours or kilowatts served to customers on the y-axis. That y-axis is up for us all to define. And so you can define it in a very system performance way, such as kilowatts served to customers, or you can define it in a societal way, such as how hard are people working to get their basic needs met. Next slide. And this just goes to show the role of, I think, regulation and lawmaking and that type of thing and policy in resilience. So if you look at a graph of customer minutes interrupted, this is a histogram. So it's organized in bins of low numbers of customers and minutes interrupted on the left to high numbers of customers and minutes interrupted on the right. And if we just say, okay, we're going to allow a utility to drop major event days, we're going to focus on the mean of this distribution to create a SAIDI type of metric. Then what you're doing is you're ignoring the fact that consequences scale non-linearly with the longer duration and the more widespread outages. And so what that means is you're really basically just chopping off some of what we care about with resilience, right? You're ignoring some of these non-linearities and you're really focusing on the shorter duration events and the less consequential events, almost by definition. So one thing that you'll hear from Jen after me is going to be, hey, let's start to look at those major event days separately and think about maybe a different approach for tackling those major event days on a consequence-based approach, and then continue along with our current focus on reliability by looking at the SAIDI and safety type of metrics. Next slide. And essentially what I'm proposing is that we start to really think a lot more deeply about how long duration, especially outages, cascade into consequences to our society. And this is because the grid is the keystone infrastructure. It's absolutely critical for everything we rely on as a society. And so as you think about that, it's really it's a difficult job, it's an important job, but it's also currently an externality in our power markets. that the cost of electricity, unless you're one particular utility in Texas, usually doesn't go up extremely during these critical events, and especially not equitably for different customers. Next slide. So one of the projects that DOE has invested in the past 3 years that really supports this approach is called Designing Resilient Communities. And this is a project that was meant to look at what are the goals of our communities and our society? How do we get those into something that's measurable? And then how do we take those metrics and internalize them within power system planning? And so we've been working with a collection of cities and utilities that you see here: Boston, Los Angeles, HECO with Honolulu, Norfolk, Virginia, and Dominion, and New York and Con Edison. And we've also been working on some case studies in Puerto Rico and in San Antonio. And what we're trying to do is advance the state of these metrics and then think about how to internalize them within a regulatory environment and also within a power system planning environment. And Jen will present some of the work on that. She and Synapse were highly involved, and that's what actually funded some of the work that she's going to present today. But I'm going to present a little bit of the other stuff that we've been doing as well. Next slide. So one of the things we've been doing is thinking about what are the roles within an overall integrated planning framework for resilience. And we've been thinking about roles for cities, utilities, and for regulators across different phases of the planning of the planning process. So you're thinking about what are the drivers for resilience? What do I want to be resilient to? What keeps me up at night? Then you're thinking about what's my baseline today? How resilient am I today from a performance-based standpoint? What consequences do I expect to see with my current system if I were hit with a particular threat? What are some alternatives? What could we invest in? Alternatively, what could we do from an operational standpoint? What are some of the policies that we could change to improve this stance? And then finally, let's evaluate those alternatives. So it's very similar to planning processes you've seen in the past, but we're trying to take those 4 different stages and map them onto roles for these different stakeholders. Next slide. And one of the things we've really advanced is a forward-looking metric that we think can be validated over the next few years that quantifies how hard are people working during a major event, especially a major outage. And this has a grounding in social science. We're working with the University of Buffalo on this, and this is called social burden. So this is quantifying essentially the effort that people expend and divide it by folks' household income status. And we can do this at the census block group level. You can see we've done it here for Puerto Rico, and that's in the report that's linked at the bottom of the slide. And I think it's a promising approach that I hope to extend in the future with more work on validating this approach to really say, hey, we can calculate this given alternative grid investments. If we understand the difference in outage extent and duration, then we can project how hard people are going to have it for food versus water versus shelter in the next disruption. Next slide. And we've already used this within a grid planning environment. So we've created a tool called the Resilience Node Cluster Analysis tool, which actually optimizes a section of the distribution system for the social burden metric versus capital cost. Now, of course, that is a resilience only planning environment. You're looking at burden and then you're looking at capital costs. You're not looking at the other blue sky values that's, let's say, a microgrid could provide. And that's why I really highlighted at the beginning of this presentation that there's always going to be trade-offs, and thinking about resilience within an integrated planning environment, especially when it comes to things like DERs and microgrids, means that you have to use multiple tools and you have to consider the trade-offs between blue sky benefits and resilience benefits. But RenCat is the tool that's going to be able to look across a distribution system and highlight certain areas of that distribution system that make the most sense from a social burden perspective to invest in for microgrids. Next slide. So finally, there's a lot of work to do to validate this. We are applying this currently in Puerto Rico and in San Antonio, and in the future, I think we'll be applying it in other places in Texas after the most recent outages. And we just got some money from DOE. Thank you, DOE, to do this in Colorado Springs. So we're also socializing this with the stakeholder advisor group that I mentioned earlier, and Synapse and Converge are on that team helping us do that. And finally, the validation of this, I think that's really key, right? So how do we get ground truth for a metric like social burden? Well, there's data focus approaches, and then there's survey focus approaches. There's also how do we improve that model from a precision standpoint, and Illinois is helping us to do that. So there's a pretty broad team helping us to do this going forward. But again, that Design Resilient Communities project is ending this year. So we are certainly looking for additional opportunities to work, especially with public utilities commissions, to extend this approach. Next slide. And I think this is my last. I'll just leave you guys with, there's a lot of talk on equity recently, and I think that's well-deserved. Thinking about equity, I don't think we should only think of it as equity within the affordability domain for our power system and for our society. There's a huge resilience component to equity. And we saw this with the events in Texas, where certain folks on certain circuits were really struggling and other folks on other circuits were just fine, right? And the equity of that approach was probably not considered when planning out that power system and that operational strategy. So we think that social burden can be one of the first metrics to start to do so. And obviously that needs to live within one of these integrated multi-dimensional planning environments where you're considering, are we equitably resilient? Are we equitably sustainable? And are we equitably affordable and efficient? So that's what I'll leave you with today, and I'll turn it back over to Chair Zalewski. Thanks.
Thanks, Bobby. That's great. I am really happy to hear that you're thinking through these important metrics like social burden. That's intriguing. Just to follow up, and you had that great picture of the three-legged chair. How do you see resilience as being a key element of a more equitable energy system? If maybe you could expound upon that a little bit more.
Yeah, thanks. So essentially using something like social burden or an approach that really thinks about when our grid does go down, does it go down more often, more frequently, or longer for the most disadvantaged among us is a place to start. But then extending that to what are those communities is lacking during those types of events? Are they more lacking food, more lacking water, communications? Really what are the social impacts of those outages, and how do we most cost effectively improve those social impacts? So it could be as simple as locating a microgrid that provides those services near that community, or it could be more difficult. Maybe that community already lives in something like a food desert. So thinking through, do we need to work with city planners to change zoning laws, or to really get those folks out of that food desert, or change the basic infrastructures that are available to them? Because we all know there's only so much a power planner can do. If that load isn't there to pick up, then I can't provide food to that community, right? If that grocery store isn't there in the first place. So I think it involves more than just regulators and utilities. I think getting our city and state governments involved in the activity is really important. But thinking what we can do together, I think from a social impact perspective is where I would start.
Thank you, that makes sense. And I just I have one more question for you. As states are increasingly thinking about clean energy standards and other decarbonization targets, as we are, for example, in Illinois, how will planning have to change to maintain or improve grid resilience in a more decarbonized system?
I think this really accelerates what we have to do on resilience, right? So we're already not great at projecting how well the system will perform during a future outage or a future threat scenario with our current set of technologies. Imagine how bad we would be at projecting how that system is going to perform when it's a renewable dominated system with a bunch of battery storage, right? A bunch of electrification as well. I don't want to say that resilience is going to be an enemy, though, of our decarbonization efforts. Absolutely the opposite. Resilience should be the best friend of our decarbonization efforts. So, if that system is not resilient, it is going to hamper the efforts on decarbonization, right? There will be more and more difficulty in building those decarbonized technologies if those decarbonized technologies can't prove themselves to contribute to resilience, because society is just not going to go for it, right? So we need to be advancing the tools such as, when you're looking at something like resource adequacy, we commonly look at the worst hour or the worst day. Increasingly, it's the worst week. It's the week in which it's really cold, it's really cloudy, and it's really stagnant for the wind that we need to plan for. So we need to change those types of approaches on the transmission system. We need to think about on the distribution system, how we're integrating our technologies such that they can provide bulk power system services, and so that they are improving things like social burden, as well as being decarbonized. So I think it takes a lot of different approaches, but we really should be putting resilience right up there with what we're doing for decarbonization.
Thank you. I do see a couple more questions trickling in, but I want to ensure that we get to all our panelists and give them ample time. So if anything, we'll circle back to the questions. So I'm going to move on to our third panelist, Jen Kallay, who researches and analyzes ways to improve utility, regulator, and community coordination and collaboration in key energy planning areas such as grid resilience, distributed energy resources, greenhouse gas emission reductions, equity, and energy justice. Jen led Synapse energy economics work on behalf of Sandia National Laboratories to research the integration of a community and electric grid resilience investment planning. This work entailed developing a series of interconnected reports to explore the challenges and opportunities in several key areas, including regulatory mechanisms, resilient public purpose microgrids, benefit costs analysis, and performance metrics. Today, Jen is going to speak to a framework for regulators to consider in the near term. Jen, I'll turn it over to you.
Thank you. And I just wanted to check that you can hear me. Great. Excellent. I changed to the phone because I was cutting in and out on my end. So thank you very much for having me. As Kerry mentioned, the purpose of my discussion today is really just to introduce you to what's really a timely and very relevant report that was just released and very, again, relevant to the topic area today, which is called Regulatory Mechanisms to Enable Investments in Electric Utility Resilience. Next slide, please. And Bobby already covered this, but this is part of a much larger project under Designing Resilient Communities. And yeah, there was a lot of different components and partners to this project. And so Synapse, as Carrie mentioned, did a series of reports. And I'm going to go through on the next slide how we got to those different topic areas. So our role here was, again, 5 interrelated reports. What we started with in this project was really a landscaping report. That was to take a look at how electric utilities and communities were interacting today in the current environment, what they were doing with one another, what kind of, how they were working together and how successful those interactions were, as a means to kind of highlight some areas where there were continued challenges and also opportunities to improve. And so we did interviews with 6 utility and community pairs in that first report, and that led us to the remaining 4 topic areas that we then went into in depth in subsequent reports: performance metrics, benefit cost analysis, the regulatory mechanisms report that I'm going to focus on today, and the public purpose resilient microgrids report. Next slide. And all of those reports are available on Synapse's website at www.synapse-energy.com. What Carrie provided was the link to the actual regulatory mechanisms report. What is here is actually the website that has all the 5 reports, as well as a performance metrics tool. So this is the broader page. Next slide. So the purpose of this report was to really look at, well, first of all, substantiate a bit why cost of service regulation might, some of the opportunities, I guess, to improve upon what's going on with cost of service regulation and why cost of service regulation may not provide adequate support for resilience investments. And so what we did was to really go beyond that and explore other types of regulatory mechanisms that are in use today that may provide an opportunity for other jurisdictions that are kind of just getting started and thinking about how they want to move forward. Where we started with this was really by characterizing some of the objectives that regulators have in the first place. These are broad reports, and there's lots of different different types of individuals reading them. You know, we anticipated a broad audience. So really we wanted to bring everybody together a little bit on what are the regulatory objectives, and then how those mechanisms may or may not accomplish some of those objectives. And we actually then went along and for each of the mechanisms identified a specific case study that we reviewed in more detail. Next slide. So we acknowledge, so first of all, this report was national in scope, and there's lots of different jurisdictions and utility models. And so acknowledge that it's pretty hard to generalize across all different types of utilities across the entire United States. However, nonetheless, we did try to do that. Regulatory objectives are not consistent necessarily, nor is there consistent terminology used. So bear with me. However, I will say that these are some categories that we typically, that we see more commonly, and not every jurisdiction has all of these, but these are ones that we have observed across the United States. We've characterized them as continuity of electric service. We stayed away from the term reliability because we are in the resilience world and it can be confusing to use the term reliability. So I apologize for the new terminology here, but we have used continuity of electric service to broaden that concept beyond reliability. We have reasonable rates, customer equity in the public interest, and then we have a cross-cutting regulatory objective of measured and measurable. Next slide, please. So then we went ahead and looked for examples of regulatory mechanisms that were tied to resilience or utilized along with resilience in jurisdictions across the United States. We identified basically, there may be other examples here. I don't want to say that this is a comprehensive list. It is not. We identified one case study to go into in more detail for each of the mechanisms that we wanted to go into detail on. And you'll notice that this language actually aligns pretty well with the poll you took up front. So we have 6 different types of mechanisms that we identified, and then one case study for each. So performance-based regulation, where we are focused in Hawaii, integrated planning, where we focus on Puerto Rico. Vermont actually has 2 different tariffs, one that's focused on private investment and one that's focused on utility investment. So we have the same jurisdiction as an example for both of those. We have enhanced cost recovery, and we examine New Jersey in that case, and securitization, where we look at California. Next slide, please. So these are extremely high-level findings that came out of the study, and we have tons of detailed findings that I actually don't have time in this presentation to go into. However, I hope we get into some of those in the discussion that follows. But what we found is, and I think you're all probably up to speed on a lot of these, is that application of regulatory mechanisms to resilience is really in the early stages. There are not that many case studies. And the ones that are, a lot of these are kind of in progress. So I will say it's kind of hard to evaluate or measure, you know, the impact that some of these might be having. They're in development still in many cases, and that development takes many years. So, you know, the jury is not out necessarily, but they're showing good direction and progress in certain areas. We do see that resilience in general is not the primary goal in a lot of these jurisdictions at this time. And so we don't see that mechanisms are kind of structured in a way to really effectively address resilience. But we do note, while there are shortcomings, that there are opportunities to address those shortcomings that could better achieve or address resilience goals. It's not the intention with this report to kind of select one of these 6 and say, this is the one that everyone should use. So, you know, we note that any of these 6 or any combination of these 6 could be successful for a jurisdiction, and it's okay for jurisdictions to select different ones, and they likely will. that's fine. And so what we're trying to do is give kind of a suite that people can look at and understand what are the opportunities and drawbacks that they might have to address if they do go that route. And we also acknowledge that in a lot of cases, multiple of these approaches may be needed to more fully address resilience. One mechanism may not be enough. Next slide, please. So I'm going to go into two of the case studies in a little bit more detail, and then we can open it up for questions. So the first one that I'm going to do, and so I apologize, first of all, it was good to see that there was a good spread on these, but I'm not sure I nailed the exact allocation that I saw on the poll. But I'm going to do the performance-based regulation in Hawaii, and then I'll address Vermont's structure on the tariffs. So I like to start out with any of these case studies by just kind of laying out the threat environment, because it's something that's not always done and it's kind of assumed that people know, but I think it's helpful to, it provides important context. So Hawaii has many, many threats. They're frequent threats and a lot of risks due to those threats. Also, they're, an island nation, so their ability to kind of collaborate with others to respond is more limited. So this performance-based regulation is a multi-year effort in Hawaii to really transform the regulatory environment. Resilience is one of many goals that they have with this transformation. One of the key goals is actually to promote more renewables and distributed generation and modernize the grid. So that's the predominant goal, and resilience is further down on the list. And so there's lots of different components to this. It's a very large initiative with a lot of different subcomponents. There's an integrated grid planning process, multi-year rate plan, decoupling, performance metrics, and earnings sharing mechanisms. And then the bottom two actually are noteworthy because they're more, I think, directly relevant to resilience. They have a cost recovery mechanism for exceptional investments. This is called the Major Project Interim Recovery, or MPIR. And then they have a microgrid services tariff as well. Next slide. So as I mentioned on this one, it's a multi-year process and it's still in development with a number of, with a ways to go. But some areas, my take on this, I guess, is that a lot of good structures are in place, but the direction, especially in terms of resilience, is not quite clear at this point. So what you see are, no performance metrics at this point to specifically, related specifically to resilience, and not really any focus on critical customers or defining different customers or geographies at this point. There's many policy goals, so it's kind of unclear how those will be prioritized in the outset, but it is clear that resilience is not the top priority goal at this point. And so what we really see is we're not quite sure, what will come out of it in terms of resilience. There's not, under the performance-based regulation mechanism, there's not as much regular updates on spending and spending allocations as in some other types of proceedings. So it will be interesting to see, where the focus ends up. And it's not clear the extent to which MPIR, that additional investment mechanism, will be leveraged and for what in particular. So there's a lot to be seen here in terms of how this plays out for resilience. Next slide. So I chose this one because this is totally different. Rather than being kind of an overarching framework, it's much more targeted with a specific technology and a specific, more specific outcome. And so really, these are two different energy storage tariffs in Vermont. Again, it's focused on battery storage. There's one tariff that's focused on third-party or customer ownership and another one on utility ownership. Again, to just set the context for the threat environment, Vermont compared to Hawaii has fewer threats, less frequent. It's not to say that they don't have them. It's just a totally different threat environment, I think, than what we just discussed. And, really, we see that it's resilience is not top of mind necessarily with the design of this program. So the focus is on reducing peak demand related utility costs. And while they say, oh yeah, and we can also provide customers with backup power during outages, it's not the focus of this initiative. Incentives for the bring your own device tariff, which is the third party or customer owner, it's scale with capacity and for customers in constrained areas. So we're starting to see some targeting and specifically to location, which is very interesting. But I think that there are some areas where if this were a resilience-focused approach, this falls a bit short. And so those areas include, no focus on critical customers, no islanding requirement, no requirement to pair with distributed generation, and caps that really limit this to a smaller residential customer, which might leave out your facilities that serve a public purpose. So with that, I will open it up and see if there are any questions. Thank you very much.
Thanks, Jen. That was great. I'm going to continue to watch how everything unfolds in Hawaii with regard to PBR. I kind of spoke at the beginning. I mentioned some opportunities that might come to Illinois with regard to things like PBR and IDP. And so I have kind of a two-part question. First, what recommendations and considerations do you have for jurisdictions that are just getting started, perhaps like in Illinois? And what role can these performance metrics play in these mechanisms?
Sure. I think in regard to the first question, I would offer up, I guess, 4 areas that I think I've heard actually in some of the other presentations. And I think this is kind of consistent across a lot of the utility planning mechanisms. So one is that there's a real need to kind of characterize and understand the threats. What are they when they're expected to occur? What are the most critical needs? And do you need to be really, do you want to be responsive during recovery? Are you looking for a quick turnaround, that kind of thing? And a lot of the current processes aren't, characterizing the threats maybe appropriately or don't have a scenario for a resilience scenario that they're looking at. Second one is, we're seeing more technology options. And we're also seeing customer and utility side options. So a lot of our planning processes don't necessarily consider every single possible resilience investment that we might want to consider, right? So it could be kind of narrow. So how do we expand that solution set or consideration of that solution set? And that includes on the benefit and cost side as well. Are we looking at, for all of those different solutions, the resilience impacts of those solutions? The third one is on the customer equity side. Can we drill down a little bit more, on a spatial level and also a customer type level, right? To look at our critical customers, to look at locations where there might be more risk or more consequence. And I think you heard Bobby talk a lot about that. And then the last one is related to in the public interest, which is, prioritization of resilience versus other goals. And then also within the resilience world, how far do we want to go, right? I mean, you can make everything resilient if you wanted to, but the cost would be extremely high. So where do you stop and where do you start? And specifically, where do you start? What's the top priority? And then can you remind me of the second part of that question? I apologize.
Sure, of course. What role can performance metrics play in some of these mechanisms that you named today?
Oh, yes. So really the metrics, this is performance metrics really define the information that all of these entities use to kind of monitor the performance of these investments. And it's really foundational for any mechanism that you have some idea of where you're headed. So really the metric development, a lot of times we'll see that comes later on. And I feel like this should really come first. Jurisdictions should use the metrics to actually select and design the mechanisms that they want to use. So having those discussions early on is really necessary. And for pretty much anything you're trying to do, having a consistent understanding of what the word resilience means is very helpful.
Yeah, great. Okay, thank you. That was wonderful. I really appreciate it. And then moving on to our fourth panelist, Leuwam Tesfai, who serves as Commissioner Genevieve Sharona's Chief of Staff and legal advisor at the California Public Utilities Commission, or CPUC, and previously served as an advisor to Commissioner Leanne Randolph. Prior to her governor's appointment to this role, Leuwam practiced in the federal section of the CPUC's legal division, representing the CPUC before the FERC. Today, Leuwam will discuss the CPUC's approach, consideration, and lesson learned. Leanne, feel free to start whenever you're ready.
Great, thank you, and good afternoon. First I wanted to go ahead and thank NARUC for having me here today. And at the CPUC in my role, I've really had the opportunity, to help lead a really diverse team of analysts, engineers, advisors, our ALJ, attorneys, in the rulemaking that was opened in 2019 on commercialization of microgrids in California and resiliency. And the reason I bring that up initially is, our state is really fortunate at our PUC to have a whole team that's working on issues related to microgrids and resiliency. And so all of the things that I'll be talking about are really, a testament to having such a solid team to work on these issues. As I said, our rulemaking opened in 2019 in response to legislation, but microgrid deployment in California certainly goes back further than that. And I'll talk a little bit about that in my presentation because I think it'll be really helpful for other states to hear about how we got where we are today. Next slide, please. So my presentation is going to be split into 3 parts. So the first is going to be focused on the California Public Utilities Commission's approach to understanding microgrid technology. Second, I'm going to delve into the regulatory treatment options that we have been using in order to support how we leverage microgrids for resiliency, but also the commercialization of microgrids in general. And then finally, I will go over a few of our lessons learned on how we've been leveraging microgrids to support resiliency in California. Next slide. So the California Public Utilities Commission's approach to understanding microgrid technology can be divided into 3 primary components: our research and development program, our formal proceeding, and also our work with the NARUC and NASIO State Regulatory Working Group and also national labs. Going first to research and development, I want to highlight the EPIC program, or the Electric Program Incentive Charge. And so that program is a research, development, and deployment program that's overseen by the California Public Utilities Commission. And the purpose of the program is to drive investment in new and emerging energy technologies and solutions that provide benefits to Californians. And this program is paid for via our public purpose program charge. And so that's a charge that is on all electric customer bills. The charge funds a variety of programs like our low income programs, our self-generation incentive program, among others. But it also includes the charge that goes towards the EPIC program. And trying to give some perspective on what this charge is, it's a really small component of the utility's overall revenue requirement. Less than 1%. It goes towards the EPIC program. But given that it has such a wide base of support from utility ratepayers, it has been able to create a consistent funding source for our research and development programs. So the program administrators that move EPIC forward pursuant to CPUC direction are the California Energy Commission, our state energy office, as well as our 3 main electric utilities. So Pacific Gas and Electric, Southern California Edison, and SDG&E. And so going back to the topic of microgrids specifically, back in 2015, the CPUC gave specific policy direction to all of these program administrators to focus part of their funds on resiliency and microgrid focused projects. So to date, I think about 47 microgrid projects have been developed through partial funding from this program. And most of those are operational at this point and providing us with a lot of learnings, which we've been able to use to move forward. Of course, other microgrids exist in California outside of the EPIC funding, but given the audience here and the number of regulators in the audience, I wanted to point to how the CPUC as a regulatory agency is helping to support that research and development. Next, I wanted to turn to our formal proceeding. So for those of you that are keeping track of proceedings at the CPUC, the number is rulemaking R1909-009. The rulemaking was opened in 2019 in response to legislation from the year prior, SB 1339. And so that Senate bill directed the CPUC to take specific actions to support the commercialization of microgrids. We've leveraged the proceeding also as a venue for building understanding of microgrid technology through active and diverse stakeholders, providing comments to our staff proposals and utility proposals. And so in those stakeholders, we have consumer advocates, environmental justice advocates, DER developers, and the utilities. And so far, the proceeding has issued 3 decisions supporting the commercialization of microgrids. The first decision was really focused on, I want to hark back to Jennifer's presentation, a significant threat that's been identified in California. So we've had a number of wildfires in California, and our utilities leverage public safety power shutoffs that shut off, transmission lines and lines that are in high-risk areas that are, that's based on weather conditions, wind speeds, things of that nature, level of humidity. But that was shutting off a large amounts of power to customers. And so we've been able to leverage this proceeding and microgrids to help mitigate some of the impact of those public safety power shutoffs. And as part of the proceeding, we've also opened, we've started the Microgrids and Resiliency Working Group. And so this working group is made up of a number of staff-led working groups. So these are staff at the CPUC leading stakeholders to help prepare proposals on a variety of issues, including further streamlining interconnection processes, revisions to existing tariffs, our microgrid incentive program, looking at the value of resiliency. And so through that staff-led working group, we're able to get stakeholders together to vet ideas and generate proposals for further consideration in the formal proceeding. I also wanted to point out another approach we've taken has been, our involvement in the NARUC and NASIO Microgrids Working Group. Shout out to that group and Kira Zeidelman, who's been doing so much work to keep us moving. And so we've been able to leverage that as a venue to share our staff concept paper, as well as other learnings and learn from other state regulatory commissions. We've also been put in touch with LBNL and Sandia to look at topics like creating that rigorous analytical foundation that Bobby was talking about earlier for assessing resiliency at microgrid investment, as well as how we can build equity considerations in from the start. Next slide. Here I wanted to turn to regulatory treatment options. So first I have ratepayer funded research. I'm not going to spend too much time there, but I talked about our public purpose program charge and how we use that to fund projects like microgrids over the last number of years. But looking to utility-owned microgrids, and so here this might be a microgrid, for example, that would be owned by the utility, included in their rate base for something like enhanced resilience in a disadvantaged community, a community that wouldn't be able to afford microgrids on its own. And that's something that we're looking at through our microgrid incentive program, which was authorized in January of this year. It's about a $200 million program that is focused on creating community microgrids in disadvantaged communities, particularly those communities that have been heavily impacted by public safety power shutoffs. And so, this is an example of, an investment that would be rate-based, included in the utilities rate base. Shareholders can earn a rate of return on that. There will be some components of that program that will be expensed, so it won't go into the rate base, but, things like studies that are done, staff time, those types of components would be an expense. And so, that kind of a program would include both the rate base of a significant amount of capital infrastructure for the actual microgrid in order to build more resiliency in disadvantaged communities. I also wanted to talk about a program that is up and running that was authorized last year, which is our temporary generation program. And I also see this as an example of a hybrid between rate-based assets as well as expensed components. And so with this program, we are creating like a microgrid type environment at utility substations where we are seeing a lot of public safety power shutoffs occurring in order to keep as many customers energized if the transmission line, several miles away, hundreds of miles away that is serving them has to be shut off because it's in wildfire conditions. So through this program, we're using existing substations, which are included in the utilities rate base, and pairing them up with mobile diesel generation. And the mobile diesel generation is included as an expense rather than a rate-based item. And so part of our reasoning for that is we really see this as a program just for the near future. These, the diesel generators, the ones that we're approving are Category 4 generators trying to reduce emissions as much as possible. They can be run on diesel or hydro-treated vegetable oil where available. But, by making sure that the diesel generation is expensed rather than rate-based, we're not causing ratepayers to have to carry those costs long into the future. We're also signaling to industry and stakeholders that this is a temporary program to get us where we want to go. And so the costs for this program are booked in what we call a memorandum account, which will later go for reasonableness review before the commission, either in a future general rate case or as a standalone application. But the largest component of that program is an expense rather than rate base in order to shield ratepayers from those costs. As I said, that program is envisioned to be temporary, and we're looking into the future at cleaner microgrids at substations. And so the regulatory treatment for the study and deployment of that program, our utilities will be able to include in a balancing account. And so that gives them more certainty related to the cost recovery. And a lot of those costs are likely to be rate-based and carried by ratepayers into the future. But we're hoping that we're focused on that as an investment in a cleaner microgrid future for California. I also wanted to finally touch here on tariff changes. And these tariff changes are largely supporting third-party or customer ownership of microgrids. And so here, these changes are often supporting microgrids that, an industrial customer or any customer that can afford to have a microgrid are able to use. And so the tariff changes are really important because they help to create, a clear line of understanding between customers and the utility on how the microgrid will be leveraged and the costs associated with it, which helps with customers understanding, should they be investing in a microgrid? Should they not? Is it what they really need? But you also have to be careful with the tariff changes and making sure that we're not leaving any stranded costs on the table to be recovered by customers who aren't able to afford microgrids. So we've been able to take a multi-pronged approach in order to leverage microgrids for resiliency, but also giving customers choice as they want to move forward potentially with microgrids. And those microgrids might be for a resiliency purpose, like the other speakers talked about, but they could also use it as a form of bill arbitrage and being able to leverage time of use rates or critical peak pricing better by having a microgrid on site. Next slide. Thank you. So I know that I'm a little bit over time, so I'll go through this portion really quickly. So I already talked about leveraging research and development microgrids. And so in the real world scenario, I want to give the example of the Blue Lake Rancheria microgrid. I'm sure many people here have heard about it, but it was an EPIC funded microgrid that's located in the far north of California. And during public safety power shutoffs, it has been able to support thousands in the community to come charge their phones, plug in medical equipment, things of that nature. So it really shows how research and development is able to be leveraged in a real world scenario. The second, here deploying backup power to create microgrids to support substations. The temporary generation program that I spoke to about earlier, it was able to be leveraged to keep about 62 different substations at different points powered during public safety power shutoffs. And so that has kept thousands of customers energized during this resilient scenario. And then finally, what I was speaking about earlier, the transition to clean microgrids to support substation resilience, with a focus highlighting our microgrid incentive program, which is focused on disadvantaged communities that have been really hard hit by public safety power shutoffs, and making sure that they are empowered to leverage microgrids in their community to keep everyone there safe and energized during these resiliency events. So that's my last slide, or I guess the last slide has my email address if there are any questions or follow-up. Thanks.
Thanks, Leuwam. This was a great presentation. California is a leader on so many policies and initiatives, and the rollout on microgrids on a statewide scale is no exception. I do have a question. We obviously, the theme here today is resiliency, but in addition to, or maybe it is only resiliency, what are some of the leading drivers for microgrid deployment in California?
That's a great question. So the proceeding, as I said, has largely been related to resilience in the face of climate change. So I think climate change is a large driver, and wildfire is a component of that climate change. And so when the utilities have to take actions like public safety power shutoffs to prevent utility infrastructure from igniting a wildfire, we've been able to leverage microgrids as part of a larger suite of resources to reduce the impact. Of course, public safety power shutoff is not the only response to wildfires. We also have extensive technology that's been deployed on transmission and distribution lines to reduce the impact or the potential for a wildfire sparking, as well as vegetation management and enhanced inspections. But that really has been a large driver. And then a second one I'd like to bring up has been, California has moved to time of use rates. Hopefully in the future, once everyone has a handle on that, we'll be able to look at dynamic pricing and other utility rates that respond to system changes on the grid. And so a microgrid on site could help you respond to that by allowing for the solar on your microgrid to charge a battery, to be leveraged during a time of day when electricity prices are higher. So there's a lot of uses. I think climate change is probably the largest driver, but I think our leveraging of time of use rates is also another strategy to battle climate change. So I think climate change is the largest driver.
Thank you. We have about 1 minute left, and I want to be respectful of everyone's time. So I'm gonna close out. Julio, Bobby, Jen, Leuwam, thank you for taking the time to lend your expertise on this conversation. This was a great conversation. I'll make another plug for everyone to check out the study that was done through Sandia. That's in the link of the chat box. You guys, this was a really important and informative conversation. I really appreciate it. Thank you again to NARUC for putting together this panel. And then everyone, I just wish you all a great day. Thank you again for attending.